Greetings and welcome to our lesson on inequalities. Once more, I apologize for the voice. I do expect it to clear up hopefully soon. Um, I would ask you to review this section of this chart, and if you have questions, certainly bring those up. I'm not going to spend a lot of time other than to mention if you have a less than, you're going to use a parenthesis on the number line. If it's a less than or equal to or a greater than or equal to, you'll notice that we have a bracket on the number line. So please be comfortable with all three of these columns, and if you have questions on them, bring those up in our class discussion, please. Same thing with the properties of inequalities. The one thing that I'm going to remind you of is that anytime you multiply or divide by a negative number, anytime you do that, you are going to reverse the inequality symbol, okay? And we see that here. If A is less than B and C is less than 0, then when we multiply both sides here by a negative number, you notice that flips our inequality. When we divide both sides by a negative number, you notice that flips the inequality. So please be aware of that. Something I'm sure you all know and have all seen at one point, but we just need to remember that. So let's look now at our first example. And some of what we're going to do today may be a little new to you, or it may be presented in a way slightly different than what you're used to. We've got a compound inequality here. This simply means we've got more than one inequality symbol. We are going to multiply all three sides, if you will, by 3 to clear out this denominator. So negative 6 is less than 4x plus 1, which is less than or equal to 0. I'm going to subtract 1 from all three sides so that negative 7 is less than 4x is less than or equal to negative 1. And now I'm going to divide everywhere by 4. And so negative 7/4 less than x less than or equal to negative 1/4. Now, often I'm going to ask you to write the solution in interval notation. Notice we have a less than here, so this is going to be a parenthesis. We have a less than or equal to, so this is going to be a bracket, and there is our discussion, or there is our solution. For class discussion, please take a look at problems 8 and 12. For homework, please work problems 9, 10, and 13. Now, kind of a couple trick ones here as we review how to work an absolute value inequality. Here, this is actually going to have no solution since distance, which is what absolute value really is never negative. And on the same token, where's the absolute value of 5x plus 2 less than or equal to 0? Well, it's never going to be less than 0. So we just need to find out where 5x plus 2 equals 0, and that's at x equal negative 2/5. So that's example 3, problem 24 here in our notes. Let me work a bonus example in here, one more that's not in your notes. I'd like to stress that anytime you are solving an absolute value equation or inequality, you need to isolate that absolute value first. So let's go with a bonus example here. Bonus example. This is going to be the absolute value of 3x minus 7 plus 1. And we're going to solve that when it's greater than or equal to 5. Now the first thing I need to do is subtract 1 from both sides. So this is the absolute value of 3x minus 7 greater than or equal to 4. And this breaks down into 3x minus 7 greater than or equal to 4, or 3x minus 7 less than or equal to negative 4. We're going to add 7 to both sides here. So 3x is greater than or equal to 11. X is greater than or equal to 11 thirds. Or we add 7 to both sides. 3x is less than or equal to 3. We divide both sides by 3. X is less than or equal to 1. If I write this in interval notation, negative infinity to 1 bracket because it's less than or equal to union bracket 11 thirds to infinity. And let's go with a second bonus example here just to make sure that we're doing okay. Bonus example number 2. Absolute value of 3x minus 7 plus 1, this time less than or equal to 5. We subtract 1 from both sides. 3x minus 7 less than or equal to 4. And now what we're going to do here, negative 4 is less than or equal to 3x minus 7, which is less than or equal to 4. We'll add 7 to all three sides, if you will. And so this gives me 3 less than or equal to 3x, which is less than or equal to 11. We're going to divide everywhere by 3. And so 1 is less than or equal to x is less than or equal to 11 thirds. 1 to 11 thirds. And there we go. So now for a class discussion, if you would kindly work problems 18 and 20 and bring those in, have those ready to go. For homework then, take a peek at 21 and 25. Now, our next inequality we're going to look at is a quadratic inequality. And this might be something that you haven't spent a lot of time doing. We need to get one side of this thing set equal to 0. So I'm going to subtract 8x and add 15 to both sides. When we do that, we're going to find that 0 is greater than x squared minus 8x plus 15. And so 0 is greater than x minus 5 times x minus 3. Now, to solve an inequality like this may be a little different from the way you've done these before, or maybe you haven't seen these before. Draw yourself a number line, please. We know that at x equal 3, this value equals 0. We know at x equal 5, this expression equals 0. So we have divided the number line into 1, 2, 3 regions. We're going to pick test points in each region. All right? Pick test points in each region. And I am going to fill those test points into this expression here. I'm not really going to care what the value is as much as I am the sign. So let's pick, for the first region, I'm going to pick x equals 0. Now when I do that, I get 0 minus 5 times 0 minus 3. This is a negative times a negative. Negative times a negative. This is going to be greater than 0. So this is going to cause me to put a plus sign right there. And I know that all values of x less than 3 are going to cause this polynomial to be positive. Now let's pick x equal 4. Okay, again, 4 minus 5 times 4 minus 3. Well, this is a negative value. This is a positive value. Negative times a positive we know is negative. So in this region, my numbers are going to be negative. And then let me pick x equals 6 for that third region. And so what I get is 6 minus 5 times 6 minus 3. This is a positive, this is a positive. And so we know when we multiply those two together, we get a value that is greater than 0. And we needed to know where this expression was greater than 0. So from negative infinity to 3. And we're going to use a parenthesis because at 3, this expression equals 0. And we're just interested in where it's greater than 0. And then again from 5, and again a parenthesis here, to infinity. There's my solution. Okay. Now, if we look, this is where 0 is greater than x squared minus 8x plus 15. We needed to know, actually, this is where 0 is less than. I apologize here. This is where 0 is less than. Got to be careful here. This is where 0 is less than all of these, and so we need to know where 0 is bigger than the numbers. That's going to be in region 2. Our solution for this inequality is going to be from 3 to 5 because that's where 0 is greater than these values. In this region right here, our outputs are all negative, and so 0 would be greater than those. All right, and we saw that from our test point here. So we need to be a little careful about that. Please work problem number 30 and have it ready to go for class discussion. Then you can see the problems that I'm going to look at there for the homework. All right, now we look at a couple rational inequalities. And to do this, I want one side set equal to 0 just as we have it. The other side I'm going to factor, if hopefully that'll be possible. We've seen if we can't factor something, we can use the quadratic formula to help us in factoring at least quadratic polynomials. And so here, I factor that bottom, and this divides my number line up. At negative 6, this polynomial is equal to 0. At 3, and I said polynomial, I meant to say this rational expression equals 0. At 3 and at 4, this rational expression is undefined. And so now you'll see we've divided this up into 1, 2, 3, 4 regions. I'm going to pick a test point from each region. Let's pick x equal negative 7. And so this gives me a negative, because negative 7 plus 6 is negative, over a negative here times a negative here. So a negative over a positive is less than 0. So my polynomial is negative there. Region number 2, let's pick x equals 0. I like to use 0 anytime I can. 0 plus 6, positive. 0 minus 3 is negative. 0 minus 4, negative. So this gives me a positive over a positive, and that's a positive. Let's take a look at 3.5. And see what we have here. 3.5 plus 6 is positive. 3.5 minus 3 is positive, and a negative. So this gives me a positive over a negative, which of course is negative. And then let's pick x equal 5. Well, this gives me a positive over a positive times a positive is greater than 0. So we need to know where this is less than or equal to 0. And So from negative infinity to and including negative 6, this works also from 3 to 4. All right, is where this rational expression is less than or equal to 0. We have another rational expression here in example 6. I need one side set equal to 0, so a little work to do here. X minus 2 over 3x plus 5 minus 4 over 1. This is less than or equal to 0. Common denominator. X minus 2 minus 4 times 3x plus 5 all over 3x plus 5 less than or equal to 0. X minus 2 minus 12x minus 20 over 3x plus 5. This is less than or equal to 0. Negative 11x minus 22 over 3x plus 5 less than or equal to 0. Factor out a negative 11, x plus 2 over 3x plus 5 less than or equal to 0. So you'll notice what we're looking at on a number line here. I've got a 0 at negative 2. I've got this expression undefined at negative 5/3. Okay, and so we'll pick our test points. Let's pick x equal negative 3. This gives me a negative and negative 11. Then negative 3 plus 2 is negative. Negative 3 times 3 is negative 9 plus 5. That's going to be a negative, so we've got a positive over a negative. This region is negative. Now, from negative 2 to negative 5/3, keeping in mind negative 5/3 is negative 1 and 2/3. So let me pick negative 7/4 here. X equal negative 7/4. Well, negative 11. Negative 7/4 plus 2 is positive. And then negative 7/4 plus 5. Well, that's going to give me a positive result. So we get a negative over a positive, which again, let's see here. Need to make a correction. Let's see. When I put negative 7/4 in down here, this gives me negative 21/4 plus 20/4. That's going to make that a negative value right there. It's going to make that a negative value right there. And so that'll make it positive. And then if we pick x equals 0, we get negative 11. 0 plus 2 is positive, and then 3 times 0 plus 5 is positive. That will be negative. So I need to know where this guy is less than or equal to 0. And I look, we're going from negative infinity to negative 2, and I'm going to include negative 2 because the rational function is 0 at negative 2. And then again, parentheses, negative 5/3 to infinity. Now we take a look at example 7, which is problem 48. From our problem set here, we need again one side set equal to 0, x over 2x minus 1 minus 3 over x plus 2 greater than or equal to 0. This is x times x plus 2 minus 3 times 2x minus 1 over 2x minus 1 times x plus 2, and this is greater than or equal to 0. Now let's multiply this out. X squared plus 2x minus 6x plus 3 all over 2x minus 1 times x plus 2 greater than or equal to 0. X squared minus 4x plus 3 all over 2x minus 1 times x plus 2 greater than 0. Now I'm going to factor the top, x minus 1, x minus 3 over 2x minus 1 times x plus 2. This is greater than 0. Alright, now we're ready to divide our number line up. At x equal 1, this rational is 0. Same thing at 3. At x equal 1/2, we have an asymptote. Same thing at -2. Okay, so we've got 5 test regions here to consider. 5 test regions here to consider. And so let's pick x equal -3. And again, I'm going to just plug them in right here, folks. This is going to be a negative times a negative over 2 times -3 is negative minus 1, negative. -3 plus 2 is negative. This is going to be greater than 0. Let's pick x equal -1. This will be negative times a negative over a negative times a positive. Well, this is a positive over a negative, which is going to be negative. Let's pick x equal 1/4. 1/4, yeah. Didn't use 0 in this one, I guess. 1/4 here minus 1 is negative. Times another negative over a negative times a positive. So we've got a negative over a negative, we've got a positive over a negative, less than 0 here. And then if we look at x equal 2, we've got a positive and a positive here. We've got a positive and we've got a positive. So this is greater than 0. Then if we look at x equal 4, we've got a positive times a positive, positive times a positive. Okay? And we need to know where this thing is greater than or equal to 0. Guys, I'm sensing something I need to look at here. Let's go back and revisit 1/4 for just a moment. Okay, 1/4 minus 1, that's a negative. 1/4 minus 3, that's a negative. Here we may, let's see, 1/4 times 2 is 1/2 minus 1, that's a negative. And then 1/4 plus 2, that's a positive. But I realize that 1/4 is actually over here. And that's where I've made my mistake. So let's correct this here. Let's correct this. And my apologies. Let's pick x equal 3/4 instead. Okay, my apologies there. 3/4 minus 1 is negative times 3/4 minus 3 is negative. 3/4 times 2, well, that's 3/2 minus 1. That's a positive. And then 3/4 plus 2, also a positive. So this is greater than 0. This is greater than 0. And now I have a feeling I should look at 2 one more time. If x equals 2, looking right here, if x equals 2, 2 minus 1 is positive. 2 minus 3, however, is negative. And so I apologize for that mistake. And now a negative over a positive A negative over a positive is negative. And now I believe we are ready to go. Let's see where this thing is greater than or equal to 0. This is going to be from negative infinity to negative 2, union 1/2 to 1. We get to include 1 since the rational is equal to 0 at 1. And then again from 3 to infinity. Now for class discussion, please work problems 36 and 42, and then you can see the problems to work for homework. Let's take a look at a couple applied examples here of where we can use inequalities. To treat arrhythmia, a drug is fed intravenously into the bloodstream. Suppose the concentration C of the drug after T hours is given by this function. If the minimum therapeutic level is 1.5 milligrams per liter, determine when this level is exceeded. And so we need to know when 3.5 T over T plus 1 is greater than 1.5. We know this is going to be 3.5 T over T plus 1 minus 1.5. This is greater than 0. 3.5 T minus 1.5 times T plus 1 all over T plus 1. When is that greater than 0? 3.5 T minus 1.5 T minus 1.5 all over T plus 1 greater than 0. So we've got 2T minus 1.5 over T plus 1. When is this greater than 0? Well, now remember, we need to know when 2T minus 1.5 equals 0. 2T equals 3 halves, and so T equals 3 quarters. And so now we make our number line. Here's 3 quarters. Here's -1. Okay, we pick our test points. X equal -2. Top's going to be negative. Bottom's going to be negative. This will be greater than 0. And of course, that's not going to make any sense. So we can really ignore the -1 there. Here's 0. Let's look at 1/2. X equal 1/2. 2 times 1/2 is 1 minus 1.5. That's going to be a negative. 1/2 plus 1 is greater than 0. Whoops, excuse me. Whoa. This should go right here. And then when x equals 2, well, 2 times 2 is 4 minus 1.5. That's positive. 2 plus 1 is positive. And so we've got a positive result here. So the level is exceeded when T is greater than 3/4 hours or 45 minutes. Our final example here is problem 60 from the homework. It says if an object is projected vertically upward from ground level with an initial velocity of 320 feet per second, then its distance s above the ground after t seconds is given by this function. For what values of t will the object be more than 1536 feet above the ground? We need to know when -16t squared plus 320t is greater than 1536. Of course, we need one side set equal to 0. And then we are going to, I'm going to divide by a negative everywhere, and that's going to flip the inequality. So I've got 16t squared minus 320t plus 1536 less than 0. And now I can divide everywhere by 16. This will make life easier. So t squared minus 20t plus 96 is going to be less than 0. And thankfully for us, this will factor into t minus 8 and t minus 12. Okay, so here's our number line, 8, 12. Of course, doesn't make any sense to look beyond 0 over here. So let's pick, we've got 1, 2, 3 regions that we care about. If x equals 1, we've got a negative times a negative, which is going to be greater than 0. And then if x equals 10, we've got a positive times a negative, which is less than 0. Then if x equals 14, we've got a positive times a positive, which is greater than 0. All right, so for what values of t is this thing less than 0? That'll answer our question. And the object is above 1,536 feet between 8 seconds and 12 seconds. And so now please work through problem 62 for class discussion, and you can see the problems there to work for homework.